I'm Anil Kumar. Welcome to my series on trigonometry. We'll now discuss compound angle formulas. In this particular video, we'll actually do derivation of all these formulas. So here is a list which you're going to use many times, so keep it handy. So we'll begin with the a plus b formulas for sine, cosine and tan. Prove formulas for double angle, cos 2x, sin 2x and tan 2x. And from here, we'll derive half angle formulas. We'll also get into product to sum and difference, and also from sum and difference to product formulas. So now let's begin and see how to work with compound angle formulas. Begin with the sine function and derive new formulas from what we know. We know that sine a plus b is equal to sine a cos b plus cos a sine b. For sine a minus b, this sign changes, rest remains same. So we have sine a cos b minus cos a sine b, correct? So let me call this as our equation number 1 and equation number 2. Now what we need to see here is that what happens when we add them up. That is to say, if I do equation 1 plus equation 2, what do I get? I get sine a plus b plus sine a minus b equal to, when you add these two terms cancel out and they double, so we get twice sine a cos b. Does make sense, right? So this is, in a way, writing from product to sum. Let me rearrange. So what I will do now here is write this side as 2 sine a, I'm just rearranging, cos b is equal to sine a plus b plus sine a minus b. So I could write this also as sine a cos b, which is product of sine and cosine, is half of sine a plus b plus sine a minus b. You see that? So we derived another formula which is called product to sum, using a plus b and a minus b for sine, correct? So we'll just call this as formula number 3 for the time being. You get an idea. Now let us play around a bit with the formula we just derived, this one, right? So what we are going to do is we are going to replace a with alpha plus beta by 2. And we are going to replace b with alpha minus beta by 2. In the formula, twice sine a cos b equals to sine a plus b plus sine a minus b, right? And see what happens. So this is what we are going to do next. And see what happens. So once we do that, we'll get kind of reverse, which is at present we are saying product to sum, we'll get sum to difference. Let's see how. So let me rewrite the equation we just got, which is 2 sine a cos b is equal to sum of sine a plus b and sine a minus b. Now we'll do a substitution. That is to say, we will write a as alpha plus beta by 2, and we'll write b as alpha minus beta by 2, right? In that case, left side we get like this. What happens to a plus b? In that case, a plus b will be equal to alpha plus beta by 2 plus alpha minus beta by 2. So when you combine these, what do you get? 2 alpha over 2, or basically you get alpha, right? If I do a minus b, you get alpha plus beta by 2 minus alpha minus beta by 2. And that is equals to alpha minus alpha is gone. This becomes positive, so we get 2 beta by 2, which is beta. Correct? So we can replace all these terms. Once I do that, what do I get? So instead of a, I am writing alpha plus beta by 2. So the equation becomes twice sine of alpha plus beta by 2 times cos of b is alpha minus beta by 2 equals to a plus b is nothing but alpha, so we get sine alpha, plus a minus b is beta, so we get sine beta. Correct? So now we have written from sum to product. So we could write this as another formula, which is sine alpha plus sine beta equals to twice sine alpha plus beta by 2 times cos alpha minus beta by 2. So that is called sum to product. So I hope that is clear, right? So this is what we call sum to product formula. See how easy it is to get all these formulas. So they are all very much related. Perfect. Now we'll work with the cosine part, right? Cos a plus b and cos a minus b. So we know that cos of a plus b is equal to cos a cos b minus sine a sine b. Perfect. And cos of a minus b is their sum plus sine a sine b. So let's call this equation as, let's say, 5 and 6. In that case, if I add equation 5 and 6, what do I get? Just add them up. Those terms cancel out. So we get cos a plus b plus cos a minus b is equal to twice cos a cos b, right? So we do get a product to some form. That is the product, which is 2 cos a cos b equals to cos a plus b plus cos a minus b. Perfect. Now, we could also find the difference, just as we did in our previous exercise. If I do equation 5 minus equation 6, what do I get? I get cos a plus b minus of cos a minus b equals 2. The first two terms cancel and I get negative of these two. So negative of twice sine a sine b. Correct? Or in other words, I could write this as, sometimes we prefer to write with, we make that part negative, but either way. So I'll just write this as twice sine a cos b, sine b, as equal to, so we're taking negative sign, right? So negative of cos A plus B plus cos of A minus B. Does it make sense to you, right? So we kind of switch the sign. So we get the formula for product to sum, and here we have two different formulas. So we'll call this as our formula number 7 and this as formula number 8. Okay. So in the next exercise, we'll do the same substitution of A being sum of alpha and beta divided by 2 and B as difference of alpha and beta divided by 2 to get our new equations, which will be very interesting to watch. So let's move on. Now here we'll use the previous equations which we derived. One was 2 cos A cos B equals to sum of cos A plus B, right? And A minus B. And the other one which we derived was minus 2 sin A sin B, which was their difference, right? Which was cos A plus B minus cos A minus B, correct? Now we'll do the same substitution. That is, we'll write A as alpha plus beta by 2. We'll write B as alpha minus beta by 2. So what is A plus B for us? So A plus B will be, when you add these two, we get just alpha. And A minus B will be beta for us, right? So when you take away, we get 2 beta divided by 2. So these are the substitutions which we are going to do in our formula. So once you do that, what happens? So let's get back to these formulas. So we get twice cos A is alpha plus beta by 2. So we get cos of alpha plus beta by 2 times cos of alpha minus beta by 2. And that could be written as A plus B is alpha, so cos alpha plus cos beta. Is that clear? So that becomes, sum has been written in the product form. Look like this, right? So we could now get our formula, which is also seen as cos alpha times, plus cos beta equals to twice cos of alpha plus beta by 2 times cos of alpha minus beta by 2, correct? So we get another formula here. We'll call this as formula number 9, right? So let me write this as formula number 9, which we derived from here. Now we are going to do similar substitution to the second equation. So we get minus twice sine alpha plus beta by 2 times sine alpha minus beta by 2, and that should be equal to cos of alpha minus cos of beta. So the difference of cosines basically, which is cos alpha minus cos beta, can be calculated from the product. So it is 2 times sine of alpha plus beta by 2 times sine of alpha minus beta by 2. So there is some repetition here, but I hope it helps to remember these formulas and also register in our mind how to relate them. So even if you forget the formulas, you can always derive. That's the whole idea. So I hope you are understanding and appreciating this concept. The double angle formulas, let's begin with sine. Sine A plus B is what? It is sine A cos B plus cos A sin B. Now if I substitute B with A, then what do I get? I get sine A plus A, right? So I'm replacing B with A. I get sine A cos A plus cos A sine A. So that gives us the double angle formula, sine of 2A, right? Twice the angle A is 2 times sine A cos B, right? Sine A cos A. So this is the double angle formula for sine. We'll call this as our equation number 9. Now let's derive the double angle formula for cosine. Same strategy. What is cos A plus B equals to? It is cos A cos B minus sin A sin B. Now if I replace B with A, I get cos of A plus A. So we get cos A minus sin A sin A. So that means cos of 2A is basically equal to cos square A minus sin square A. I mean, this is A, right? Sin square A. So that is our 10th formula. So we call it a double angle formula. Okay. Now the interesting part here is that cos 2A, this formula can be written in many different ways. Since we know that sin square A plus cos square A is 1, so you could actually write cos square A as 1 minus sin square A. So you get a different formula. You could also write sin square A as 1 minus cos square A. Correct? So if you do these substitutions, then we get 3 other formulas, rather 2 other formulas from cos 2A itself. So let's see those formulas now. So what we have got here is cos of 2A is basically cos square A minus sin square A. Now I could write cos square A as 1 minus sin square A, right? So if I replace cos square A as 1 minus sin square A, we already have minus sin square A here. What do I get? I get 1 minus 2 sin square A. So we have another form of cos 2A formula. Let me highlight this also, right? So which is cos 2A equals to 1 minus 2 sin square A. If I do the other substitution, which is cos 2A equals to replacing cos square A with 1 minus, this time with sin square A. Okay, so let me rewrite. Okay. Let's make this cos. So it is cos square A. Replacing sin square A with 1 minus cos square A. In that case, cos 2A will be, let's rewrite this, open the bracket. Cos square A minus 1 minus minus becomes plus cos square A. So that gives you 2 cos square A minus 1. Got it? So that is another formula for double angle for cosine. So what do you really see in trigonometry? That it is very easy to derive these formulas. Now important part here is that if I replace 2A with, let us say, theta, then A becomes theta by 2, and that gives us half angle formulas. Do you get it? So that's what we'll take up next. And now Also, I'll write down what tan double angle formula is. Let us also derive the double angle formula for tan ratio. So we know that tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. Now if I write B equals to A, then what happens? In that case we get tan of A plus A, which is tan 2A, and numerator is tan A plus tan A divided by 1 minus tan A times tan A. So we get the formula for tan 2A, which is tan 2A equals to 2 tan A divided by 1 minus tan square A. Correct? So with that, we get all our double angle formulas. So let us summarize all these formulas. We have sine 2A, which is 2 times sine A cosine A. Then we have cos 2A, which is cos square A minus sine square A. This could also be written as 2 cos square A minus 1 or 1 minus 2 sine square A. And here we have tan 2A formula, which is 2 tan A over 1 minus tan square A. So I hope that is absolutely clear, right? Now we'll take a lot of application questions based on this. From here, we are going to do a couple of things. We are going to generate half angle formulas. The substitution, of course, is 2A equals to theta. So A equals to theta by 2. So you get half angle, right? So before going there, let's also look into like 3 theta angles, right? So let's take one example and then we'll go to our formulas. We'll have many questions based on these formulas in following videos. Now let's talk about triple angle form for sine. That is to say that if I have to find what is the formula for sine 3 theta, what can I do? I can rewrite this as sine 2 theta plus theta, correct? And then expand it using the compound angle formula, sine A cos B plus cos A sine B. So I could write this as sine of 2 theta times cos of theta plus cos of 2 theta times sine theta. Now we know our double angle formulas. Replacing these with the double angle formulas, we could derive expressions for sine 3 theta. Perfect. So for sine 2 theta, I'll replace it with 2 sine theta cos theta. And here we already have cos theta. Now with cos 2 theta, you have 3 different forms, right? So let's use the one which is difference of squares. Cos square theta minus sine square theta. And we have sine theta here, right? So let's now expand this and try to simplify. So what do we get? We get 2 sine theta cos square theta plus cos square theta sine theta, and here we have minus sine cube theta. Correct? Now these two terms can be combined. So we have 3 sine theta cos square theta minus sine cube theta, right? So that is also a form which can be utilized. But what you could also do, you can move forward and replace cosine with 1 minus sine. So we'll continue and write another form. So we have 3 sine theta replacing cos square theta by 1 minus sine square theta. Okay, let's replace. what do we get? So we get 3 sine theta minus 3 sine cube theta. We already have 1 minus sine cube theta. So that gives you another formula, which is 3 sine theta minus 4 sine cube theta. Do you see that? So let me rewrite this formula here. All terms are in sine. Do you notice this? So we could get this formula as equal to 3 sine theta minus 4 sine cube theta. So likewise, as an exercise, you could derive formula for sine 4 theta, cos 3 theta, cos 4 theta, and so on. Perfect. So let that be an exercise. We are almost at the end of our derivation for the formulas which we began with. Now let's look into half angle formulas. You got an idea. We know now that cos 2a is basically equal to 2 cos square a minus 1. Now this formula can be rearranged and we can get half angle formula, correct? So if I rearrange, I get 2 cos square a is equal to, bringing 1 to the other side, I could say 1 plus cos 2a, correct? Now we are going to make a substitution. That is, we will now write a as equal to, rather we'll write 2a as equal to theta. In that case, a will be equal to theta by 2. Half angle, that is what we are interested in. So if I make that substitution, this particular formula becomes 2 cos square theta by 2 equals to 1 plus cos theta. Is that clear? Now we can isolate cos theta, right? So we get cos square theta by 2 equals to 1 plus cos theta divided by 2. And here is our half angle formula, which is cos theta by 2 is square root of 1 plus cos theta by 2. And whenever you do square root, you have to write plus or minus, right? So both values. Is that clear? So we get one formula for half angle of cosine. Now if I begin with the other form of double angle formula for cos, which is cos of 2a is equals to 1 minus 2 sine square a. Isolating this time, 2 sine square a will be equals to 1 minus cos 2a. Making this substitution, we get 2 sine square theta by 2 equals to 1 minus cos theta. Isolating, we get sine square theta by 2 equals to 1 minus cos theta divided by 2. Perfect. Now we can write what is sine theta by 2. So this is square root of 1 minus cos theta divided by 2 plus minus. Is that clear? Perfect. So we have got both the formulas. Now from these formulas, we can actually derive the formula for tan theta by 2, right? So we could say that tan theta by 2 is equal to sine theta by 2 divided by cos theta by 2. Perfect. So that gives you tan theta by 2 formula. So dividing this term by that, what do you get? We get tan theta by 2 equals to plus minus square root of 1 minus cos theta divided by 1 plus cos theta. by 2 cancel. Do you see? Half of that cancel. So that is your tan theta by 2 formula. Is that clear? So from this exercise, we have learned how to derive formulas for double angles and also how to derive formulas for half angles. Correct? Now in many applications, we are actually also using that square formulas, right? So I'm going to highlight these formulas also. They are very important. So in trigonometric ratios, if you get cos square theta by 2, it could be written as 1 plus cos theta by 2. Same is the case with sine square theta by 2, right? So I'm highlighting these formulas also. Normally, we are converting equations in sine and cosine, so I'm not writing any formula here. However, let's write down, for tan square theta by 2, I could write, let me write here. For tan square theta by 2, the formula will be plus minus 1 minus cos theta divided by 1 plus cos theta. Is it okay? So many trigonometric identities, we may use these formulas to answer many questions. Correct? Now, taking these formulas, let us have an exercise for you. Find what is the value of cos pi by 12, for example, right? So that is half of pi by 6. Perfect. You could do this, or let's say find what is the value of sine pi by 8, for example. Correct? So that is half of pi by 4. So that kind of give you a lot of variations. So I mean exact value. Value of cos pi by 2. So let this be practice questions for you. Apply the formula and get the result. I hope that helps. So that brings us to the end of this particular video. We have done derivation for all the formulas which we wanted to do. We have come to an end of this video. I hope you have learned how to utilize these formulas in developing new formulas. This list is extremely important, and we are going to use it in solving trigonometric identities, finding exact values of trigonometric expressions, and later on in calculus. I hope you enjoyed the journey. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks a lot for your time and all the best.